I'm Anil Kumar, and here is an application where we are going to use the equation of line in slope and intercept form. So consider the graph here for this particular question. The altitude time graph of a balloon ascending is shown in this particular graph. What you need to answer is, how fast is the balloon ascending? So that's the question. And what does the altitude intercept signify? Write an equation to model the situation, correct? So these are the three questions for you. You can pause the video, answer these questions. So let's begin. How fast is the balloon ascending? So for A, we are looking for rate. How fast? Rate of change, correct? So rate of change, we should try rate of change, which is slope for us, correct? Because slope M is rise over run. So if you find rise over run, you can find rate of change. To find rise over run, we need 2 points. Let's consider this point and one more on the particular line. So I will consider a point far away, let us say this point, and then we'll do some calculations, okay? So if I consider these 2 points, then what do I have? Let me make a triangle here. So the rise is, this value is for us 45, right? So the rise is 45 is this value, and we started with 25. So it is y2 minus y1, which is 45 minus 25, correct? So that is the rise, and the run is, x value is 4 and this is 0. So it is 4 minus 0, right? So that is rise and this is run. The other way to look into it is kind of like this. The coordinates for the point, let us say B, are 4 is x value, y value is 45. Coordinates for point A are, let me write here itself, 0 for x and 25 for y. So that is A and B, right? So we can write this rise as change in y, which is y2 minus y1 divided by x2 minus x1. That's another way of doing it, right? You could read from the graph, you could write like this. And what is y2 minus y1? 45 minus 25 divided by 4 minus 0, right? 4 minus 0. So that gives us 20 divided by 4, which is 5. So the slope is 5. Now the question here is, how fast is the balloon ascending? Now whenever we have an application question, we have units associated. Altitude is given in meters. Do you see that? Time in seconds, right? So therefore, we will answer like this. We'll say our answer is balloon is ascending. So it is ascending at the rate. So rate is a better word to use than slope. At the rate of 5 meters, this unit 45 minus is in meters per second. 4 minus 0 is in seconds, right? The units are, these units are in meters, right? And denominator is in seconds. So the units are meters per second. I hope you appreciate it, right? So I'm doing it in detail so that you understand the concept. This is very important application question. We'll have a couple of similar ones on distance, time, and related, okay? Now let's look into the second part, which is, what does the altitude intercept signify? Now what is altitude intercept? So this graph intersects y-axis, which we are writing as altitude, at 25. So what does that 25 value signify? This is the question. So for part B, what does it signify? So we can say A-intercept in short signifies, so that's the point from where the balloon was released, right? So at t equals to 0, so this t equals 0, so balloon was probably released from this point, right? So balloon was released at this particular point, right? Or we started checking the height of the balloon from that instance of time. So at t equals to 0, that is a value, and that is Yeah, so that could be one of the explanations, okay? Now part C is write an equation to model the situation. Now if you compare all this with the general form, which for us is y equals to mx plus b. So let me write here slope-intercept form is y equals to mx plus b, where m is slope, in this case rate of change, and b is the intercept of the y-axis, which is representing altitude, right? So knowing all this, we can now write down the answer for C, which is y in our case. Let me write this as, so in general, y equals to mx plus b, y is represented by altitude a. So let me write this as a and this as t, right? So these are the variables which I am using. So I say altitude a equals to, slope is 5, so we say 5 times t, the time, plus the initial point, which is 25. Do you see that? So a equals to 5t plus 25 is the equation for this particular graph. As you can see, y-intercept. So wherever the line crosses y-axis is now representing the variable a. The x-axis representing time, t. So where in this equation, t is the independent variable time in seconds, a is the dependent variable representing altitude in meters. You should write that also, correct? So I hope with this we have explained the situation and you understand how we can relate real life situations with the help of this simple, basic and very important equation of line. Thank you and all the best.